Speaking after Minko's keynote, there's absolutely no pressure at all. Absolutely no pressure at all. Yeah, we've heard it. Thank you for that amazing keynote. It's really cool where Angular is heading. All the things which are happening are running towards signals. And yeah, we've heard that signals are a main topic which has been discussed lately a lot in the internet. And we have a lot of blog posts and we have a lot of videos about it. And I just want to short recap what signals basically are. So what are signals? Well, signals are basically nothing else than the value which we can have plus the ability to say, hey, I changed. Okay, so we can unbox a signal. It's just a function. We can call the value, so we get back the value, but it has the ability to say that I changed. Okay, so what can we do to create a signal? Well, we just can import the signal method and we can pass it a value. In this case, we're saying, hey, we have a to-dos, and then we're passing an empty array. So signals always have a value, in this case, an empty array, and we can say, this is my to-dos signal in this case. We've all seen that before, you know. What can we do with signals? Well, first of all, we can type them. Okay, so they're generic. So here we can see that we have a to-dos array. We're passing an empty array. Like I said, we can call them, so we can unbox the value and saying, I would like to have the value which is inside, which is always synchronous. Okay, then we can set the signal. So regardless of what's inside, we are taking a value and overriding it and saying, this is the value of my particular signal right now. Okay, so we can set the value, and regarding of what is inside of that particular signal, we can say, I would love to update, and I would like to take care of the items I have literally inside, and then I would do something with them, like extend them or remove one item and stuff like that. Okay, so that's the basic API of signals. But there's more. Okay, we also have things like computed and effects. So if we take a look at the computed here, we can take computed, which is also a function, and takes a callback function, when we want to have derived values from signals. So if you have a signal and you have a value inside of that signal and you want to derive values from this, you can use computed, and based on the value of that signal, you are doing, like in this case, a count, which is just referring to the length property of that particular to-dos. Then we also have the effect. And the effect is basically being run and just console logging out what is inside of that computed signal we have defined in line 3. Okay, so it's referring to that, and whenever something changes, the effect will run and then print out what's happening there. Okay, let's have a look at this example. Okay, these are basically the same console logs, right? Line 3 has a normal console log. I'm console logging out the value of the to-dos. And in the effect, I also have the console log, and I'm logging out what is inside the to-dos. So that's pretty much the same code. But there's a difference between the both. So what is the difference between the two both? What is happening when we're updating a signal? How do these signals communicate underneath each other? These are all questions I would like to clarify in the next, 16 minutes. And with this, I welcome you to my talk, Angular Signals Under the Hood. I'm very happy to be here. So let's dive into the code I just showed. So what we have is, we have two console logs, right? We have the console log, which is running on line 3, and we have the console log, which is running on line 6. Same code. But what happens if the signal changes, right? If the console log on line 3 is being executed, it's being executed, printing the value out, and that's it. Okay? But if we are in the effect and the signal changes, the effect will rerun. But the line 3, the console log won't rerun. Okay? So that's the difference beside of this. And this difference is what we refer to as reactivity. Okay, so what we do when we are talking about reactivity is like the synchronization between your application data model, the values you have in your signals, and your rendered UI, to keep them updated and keep them in sync. This is what we refer to reactivity. Before signals, Angular used Zone.js for reactivity. Now we have signals, and you have seen the path in Minko's keynote, what is being done to make Zone.js optional. Okay, Zone.js was telling the framework that something happened anywhere in the application and it was being rerun everywhere. Right? With signals, we have the ability to say, hi, I changed. And we have a very fine granular reactivity in this case. But this synchronization is what we refer to reactivity. However, we also know that reactivity is based on the context we are running in. Not everything is reactive. Okay? We have seen that effects are reactive. But what else is a reactive context in this case? Well, we have reactivity in TypeScript with the effect. We have seen that. But a reactive context is also in the HTML. Okay? So what the view does in this case, when Angular reads that template, it refers to that signal saying, hey, I'm a consumer of yours. So if you change, please let me know. So it creates a connection between the to-dos in the template or the to-dos in the effect, the to-do signal in the reactive context, and the particular signal. The signal recognizes the view as a consumer and says, hey, I got you. When I change, I'll let you know. Okay? So they're making a bidirectional connection, and when it's the turn of the effect or the HTML to re-render, then the things are happening and they're like exchanging the values. So a reactive context is also referred to as a live consumer of that particular signal. They are live. They are like listening to changes. Whenever something happens, they do their work. Okay? We have live consumers, like we have seen, like the effect and the reactive context in an HTML, but we also have the part of producers. So producing new value, like we have seen in the computed. A computed is also producing a new value, or a signal itself, it's producing a new value, right? So we have consumers, we have producers, but we also have both. Think of the computed. A computed is a consumer and a producer at the same time, right? So it's reading a value from a signal, doing something, and spitting out a new value. So it's both in this case. And what Angular does behind the scenes is it creates out of this points you have, out of these signals, out of who's consuming who and who's connected to who. It's creating a reactive graph out of it, right? So it takes all the nodes, which is a computed, which is a signal, which is an effect, a reactive context, effect or HTML, and puts them together in a reactive graph. This is not visible. I don't think there are tools outside which can make that visible. But basically, we have, besides your rendered DOM with all the components, you also have a reactive graph behind it, right? And this reactive graph visualizes basically who is depending on who. And it's very interesting to dive into the source code of signals. I would all recommend you to do so. So what we find here, this is an actual, I've linked the line there. We have some methods there. I could have taken another methods. However, we have set active consumer or get active consumer, and what we return is a reactive node. So all the things inside of the reactive graph are referred to as reactive nodes. It's a node inside of the graph. Okay? So yeah, I linked the code there, and then you can see it. Let's take this example here. So we have a signal which is of to-do, it's an empty array, and an effect which is referring to that particular to-dos. Very simple, most basic example. How does the reactive graph look like for this? Okay, that's pretty easy. We have the signal on the one side, we have the reactive context on the other side. The reactive context is an effect or the HTML, and then we have the to-do signal. So what happens when the to-dos changes? So first of all, there are two phases going on. Okay, so the signal lets its consumer know, hey, I might have changed, I'm dirty. So it's pushing dirtiness through the complete graph, saying something might have happened here. It would be nice if you would if you pass by and just ask for the value. And that's the second phase. So when the effect is receiving that one of its sources is dirty, it's getting rescheduled in the microtask queue in the browser, and when it's its turn, or when HTML or Angular renders the HTML view, it refers to that to-dos and saying, hey, I heard you are dirty, please give me a new value. Okay, so these are two different phases. In the first phase, we're pushing the dirtiness through the graph, and in the second phase, the effect or the reactive context is pulling the value out. So no value is being pushed. Right? So it's, hey, I'm dirty, I'm pulling the value out. We refer to this as push-pull phase. Okay, so we are pushing the dirtiness through the graph, and then we are pulling the value out. So there is a bidirectional connection between all those particular nodes inside of your reactive graph between the reactive nodes. You can see that also here. I found a method which has a very nice comment: propagate a dirty notification to live consumers of this producer. Okay, and the method is called producer notify customers, and it's really telling consumer mark dirty. Okay, so there's the dirtiness being pushed through the graph. Okay, so this is also from the Angular source code. I see I forgot to put the link there, but yeah, you can basically see it inside of the code on GitHub. Okay, let's go back to the example. So we have the signal again, we have a to-do array which has an empty array, we have an effect which is like referring to the to-dos. However, what is when we do something like this? So we have an if clause which is always false, and we're referring inside of this, which has never been run, the code has never been run, the console log, to this to-dos. So however, Angular is running this effect and will never recognize the to-dos that it's a reactive node inside of the reactive graph because the code is never run. Okay, so here you basically have no reactive graph, you only have a signal, and that's it. Okay, so we know what live consumers are right now. Like the reactive contexts are live consumers of that particular signal. Let's have a look at this one. So we have a computed, which is just going to the to-dos.length and just referring to count, and we have an effect, which is referring to that particular count. What if we do this? So we have an effect, which is only console logging out something, right? So we still have the computed, but will the computed be rerun if this signal changes? It won't, because nobody's listening to it. So we are referring the computed to transitive live consumer. It is live when somebody's like consuming it, but if nobody's consuming it, it won't be rerun. Okay? So going back to the example where the effect is depending on the computed and the computed to the signal, how does the reactive graph look like? Well, the reactive graph is basically like this. We have a to-dos, which is a signal. We have a computed in the middle, and we have an effect on the right-hand side, which is the reactive context, or could also be HTML. Now, when the to-dos changes, what's happening is that we have the signal pushing the dirtiness to the graph, saying, hey, dear computed, I changed. Okay? And then the computed says, yep, I changed as well. So then it's Angular's turn, microtask queue, when the re-rendering comes, or the browser is executing this effect, or coming to the effect saying, hey, I'm interested. The effect is going, saying, dear computed, I heard that something might have changed. Can you please give me your value? And the computed says, I've got no idea what my value is. I have to ask where I'm referring to, which is the to-dos, basically. Right? Asking that thing, and then the values are being like pulled through the graph. But even on this case, Angular is going a little bit further. Angular introduces something like versioning, which we have inside of the reactive graph. Okay? So versioning is being used to actually notify or to actually make sure if a value really changed or not. Okay? So it's like going a little bit further there. So what we have is, if you take a look at the interface of the reactive node, you can see the consumer node and the producer node extending the reactive node, but we have the interface of the reactive node. And what we have here is like a dirty flag, which we have seen before because the dirtiness is pushed through the graph. But then we also have that version property. And the version property is just a number. It's just an integer and it's being increased, right? And the version only changes if the value really changed, which means if the reference changed. Okay? So, if we take a look at the source code of Angular right now, we have a signal set function, and we have a signal value changed function. Okay? And the signal set function is checking, hey, if the node, so the current value, is not equal the new value, I'm updating the value of the particular node, and then I'm calling the signal value changed function. And the signal value changed function then updates the version. So the version is only being updated if the value really changed. And the value changed You can see that here in this example. We have the to-dos again. We have a count, which is computed on the length. We have an effect, which is referring to that computed count. And then we are really updating the items. We're saying we're taking the items. It could be like, imagine there are 3 items in it, and we are adding a 4th. So how does the reactive graph look like? Let's go there again. So we have the to-dos, which is a signal. We have the computed in the middle, and we have the reactive context and effect or HTML on the right-hand side. So the dirtiness is pushed through the computed. And then the computed says, okay, I'm dirty as well, so please, dear reactive context, do your thing. Okay? And then, when it's time for the effect or for the rendering to run, what it does is it asks, hey, dear computed, I heard that something was going on. You are dirty. But did you really change? And the computed says, I don't know. Well, I've got no idea. So I'm referring to the to-dos, asking, hey, did you really change? I know you're dirty, but did you really change? Okay? So what the to-dos now is doing, it's saying, yes, my version actually was increased. So I changed. Then the computed is being calculated, which means it's being rerun again. That's the callback function you pass. And when it's being recalculated, it refers to the to-dos, pulling the value out. And then it knows it's being calculated. It knows now the items go from like 3 to 4 or something when you have added something. And then it tells the effect, yes, in fact, I did change. My version changed. Okay, because I've got a new value. And then the effect is also recalculating. And when it's being recalculated, it refers to that computed value, pulling the value out. Okay, so let's take one of the last examples, something like this. So we have a to-dos, and we have a count, and we have effect, same as before. But this time, we are updating with the same array as before. So what we're doing is we're changing the reference, but we are not changing the length of the items. So reference changed, but not the count. Okay? So now we have like no change because we didn't change the array, but we have a new array. So what happens, that's the line where the magic happens. And this is how the default equals method is implemented by the Angular team. You can, again, look that up. So the object is or is a reference equality. Right? You can overwrite that if you want to. You can pass your own like equals function. Okay? So right now, how does the reactive graph look like? Well, we have a to-dos. We have the computed, we have the reactive context. Again, the dirtiness is being pushed through the graph. The effect is then being scheduled, and when it's its turn, then it says, hey, I'm asking you, computed, I heard something was going on. Did you really change? And the computed says, I don't know, I have to ask myself. Okay, to-dos, did you really change? Well, in fact, the to-dos did change because we have a new value. It's a new array. So the reference equal says, yes, I changed. The version was being updated. Okay? So the computed recalculates. And with recalculating, it asks the to-dos for its value, pulling the value out, push-pull phase. But then it has the same length. So the version is not being updated, and the effect doesn't have to rerun. So it's much more efficient with this version thing, what's going on, and the Angular team did a really, really great job on that. So one of the last questions is, how does an effect or a reactive context, also a computed, keep track of their dependencies? How does that work? And Angular has something like dynamic dependency tracking to do that. Okay? So all the dependencies are not fixed. They're not read in the first time and always fixed. Let's take a look at this example here. So what we have is we have a computed, and we have an isEven, and if isEven is true, we have a getDone length, and if isEven is false, we have a getUndone length as dependency. And what's happening is that's a simple array on the reactive node, which is tracking the dependencies. So the first time when isEven is true, we have isEven and getDone length as dependency in the reactive graph. And if isEven is false, we're like throwing out the getDone length, and it's being recalculated every time the computed runs. And then we have the isEven and the getUndone length tracked as dependency. So now we know a little bit more how signals work under the hood, and I hope there's only one question left, namely, who is that guy standing in front of here? So my name is Fabian Gosebrink. I'm a Google developer expert in Angular. I'm a Microsoft MVP and a Pluralsight author, and I hope you enjoyed the last 20 minutes as much as I did. Have a great conference. Thank you very much.